Hello, in this video we're going to look at some basic chain rule derivative problems. Now remember, the chain rule tells us that if we want to take the derivative of a function that's in the form f of g of x, that derivative is going to be equal to the derivative of f evaluated at g of x times the derivative of g of x. So we're going to take the derivative of our outside function, evaluate it at g, and then multiply by the derivative of the inside function. All right, our first example, we have y equals the quantity 6x to the fourth minus 3x squared plus 4, that whole quantity raised to the 8th power. Now we don't have to use the chain rule on this one. We could multiply this and expand it into a standard form polynomial, but it would require multiplying this trinomial out 8 times. It's probably going to take you a full page of work and lots of places where you could make some arithmetic errors. But if we apply the chain rule to this, what we're going to do is we're going to take this inside function, that's going to be our g of x. We're going to take the derivative as if that were just an x. And so if we had just x to the 8th, our derivative would be 8 times that x to the 7th. This is not just an x, so we also need to multiply by the derivative of the inside. So now we need to multiply by the derivative of that inside piece, and the derivative of that highlighted portion, 6x to the 4th, is going to be 24x cubed minus 3x squared. Derivative of that is negative 6x, and then plus 4, the derivative is 0. So our derivative using the chain rule is 8 times 6x to the 4th minus 3x squared plus 4 raised to the 7th. You could, if you wanted to, go ahead and multiply out. We do have a GCF on this last piece, and you could multiply out that, or divide out that 6x, and you could write this as 48x times 6x to the 4th minus 3x squared plus 4, all of that to the 7th, and then if we pull out that 6x, we're left with 4x squared minus 1. Either one of those will get you to the correct answer on your derivative. This last one is just maybe a little bit more simplified. All right, let's do another example. This one we have y is equal to 5 over the quantity 2x cubed minus 1 cubed. Now this one again, you could expand that denominator and use the quotient rule. Lots of students will use the quotient rule on this anyway, but what I would recommend on this, when you have just a constant in the numerator, I would recommend writing this as 5 times that quantity 2x cubed minus 1 raised to the negative third. Then we don't have to use the quotient rule. To take the derivative of that, our inside piece is going to be what's inside the parentheses there. So if we treat that just like we would in x, then the derivative of 5x to the negative third is 5 times negative 3, or negative 15, times that quantity raised, and we're going to subtract 1. Negative 3 minus 1 is a negative 4. And then since that's not just an x inside the parentheses, we need to multiply by the derivative of 2x cubed minus 1, which is 6x squared. And that's going to give us, we'll go ahead and put that negative back down in the exponent. So we've got our 2x cubed minus 1 raised to the 4th on the bottom. In the numerator, we get 6 times 15. That'll be negative 90x squared, which is the same thing you would get if you applied the chain rule and the quotient rule to this problem, and then simplified it as much as you could. All right, let's look at one more example. This one we have y equals the cube root of the quantity 3x squared plus 7. Now this one, our inside function is going to be what's underneath that radical. And remember, The cube root, another way of writing that is 3x squared plus 7 raised to the 1/3 power. So when we take that derivative, again, our 3x squared plus 7 is our inside. So our derivative is going to be 1/3 times our u, our inside g, whatever we want to call it, raised. We're going to subtract 1. 1/3 minus 1 is negative 2/3. But since that is not just an x in there, we do need to multiply by the derivative of the inside, which is 6x. And we can combine our constants. 1/3 times 6 is going to simplify to 2. And so we get 2x in the numerator over 3x squared plus 7 to the positive 2/3 when we move it down to the denominator. Don't be tempted. The most common mistake on these problems is to multiply by the derivative on the inside here. Make sure that when you're doing this, and you may even want to split this up and write it as the f of g and then your g function. Your f of g in this case is x to the 1/3, g to the 1/3. And your g function is that 3x squared plus 7. So when you take the derivative, f prime of g is 1/3 g to the negative 2/3, and g prime is 6x. So when you multiply those together, you get your derivative 1/3 times our g, which is 3x squared plus 7 to the negative 2/3 times 6x. So that, if you need to split it up like that, then do that.